Next up, we have Crane Johnson with the Alaska Pacific River Forecast Center, and he's going to be talking about the Riverwatch program, which a lot of local communities are very interested in, and also us at the state level. I'm pretty interested to hear what we have on the forecast for this year. So thanks for being with us here, Crane, and take it away.
Well, thanks again for inviting us to the conference. It's a great opportunity to sort of share what we do, the joint mission we have with the state to monitor breakup each year, and then always people are interested in our thoughts on the breakup outlook. Here's a little bit of what I'll go through today. Talk briefly about breakup and ice jam flooding. We'll look at last year. It was a unique breakup, different than the last 7 years, and we'll sort of do a 2020 breakup recap. And then we'll talk about what we expect this year in terms of Alaska's breakup outlook. Go over the Riverwatch program. We've got a great video that was done a few years ago that describes the program. And then we'll talk briefly at the end about the APRFC observer program. We really rely on citizen scientists around the state to help us. They're right there. This is a photo from last year, 2020 on the Yukon River, sort of what a river looks like as it's starting to break up. So causes of flooding in Alaska. Why is ice jam flooding significant? Why we always look at it? We have an ice jam flood database, and if you look at it, while rainfall is really primarily the number one driver for the number of floods, if you look at the moderate and major floods, ice jams is right up there, leading the moderate and major ice jams. And you can slice it a few different ways, but ice jam floods are the ones that impact our communities. They're costly. They end up as federally declared disasters often. So it is the biggest flood concern on our rivers generally each year for Alaska. So I'll give you sort of a preview of where we think we're at, just to get it in your head. Breakup can happen two different ways. One's a mechanical breakup, where the ice remains hard in place and we get that snow melt push of water, and that actually breaks up the ice, causes ice jams to form that clear and reform and clear. And these are the years where we get ice jam flooding. This year, we expect that breakup will trend towards mechanical. It's always a blend, and really the springtime temperatures control. And so if we look at historically extreme cases, 2013, still recent, we remember that, 2009, we remember those breakup years where we had ice jams throughout the Yukon, Kuskokwim, other places in Alaska. And so those were examples of years where it was mechanical. And there's also years where there's mechanical breakup and we don't get major flooding. 2012 is an example of that. Thermal breakup on the right, that's where the ice just rots in place, loses strength. There's low snowpack and not a significant push of water. Recent years, 2016, 2019 would all be examples of thermal breakups. And those are years where we don't expect many issues. So we do think this year, just based on ice conditions and snowpack, that we're trending towards mechanical, but still the spring temperatures will control the severity. Quick look, simple look at the two types and really what the differences are, and sort of thermal breakup, that's sort of the good kind. That's what we want to see. And then mechanical are the breakups when we can have trouble. So it's a picture of Akiak in 2009 from those ice jam year. I'll play a quick video that just shows a mechanical breakup. This is Dawson City from 2011. And Logan, do you see that play on your end?
Yep, I can see it.
Perfect. So this is a single day, Dawson City, 2011. It starts out sheet ice in place, and you'll just watch it. It actually goes through the whole process. The ice releases, we get an ice jam form, water actually rises upstream, the ice jam clears, and then we'll see several runs of ice. And so when we're out on the Riverwatch program, this is what we're trying to understand, where the ice jams have occurred, and if they have occurred, to make sure that we let local communities upstream, downstream know about the ice jam and issue any flood watches, flood warnings that we need to. This is early May, a little bit of snow there midday. And then shortly here, we'll see the river start to clear. And then an ice jam forms. Water actually backs up. If you look at the riverbank closely, that jam clears, and then we've got two significant ice runs that come through. So that's an example of mechanical breakup. No flooding occurred, but we did get the ice jams that formed. Maybe I'll just go back. We'll look at the jam one more time. We'll go to the next slide. So, and the concern is, you know, from an ice jam perspective, if that jam stays in place and then we pack those next two ice flows into that jam, it strengthens it, and then those are the situations where we get flooding. So the idea is to monitor locations and understand where these jams have occurred. You know, an example would be Galena and Bishop Rock, to identify that jam that it's occurred, and then to alert Galena that there's a jam in place and water could rise rapidly. And that was the end of that was breakup in Dawson in 2011. It's got a great hillside with perspective of the river there. Stop and go to the next slide. Okay. Would show some quick pictures of the difference between thermal and mechanical, what it looks like from the air. This is thermal breakup. This was 2016. The ice on the Kuskokwim just sat in place. On the right is near Napaskiak, and that's what we monitored for breakup that year. Another view on the left, a little earlier season, but you can see the ice has lost strength. We've got puddling, ponding, it's dark. And those are when we see it lose its strength, when it changes color. It tends to absorb the sunlight, and the ice starts to degrade. And you'll hear terms rotten, candled, but those are where we see the thermal type breakups. During mechanical, typically it'll be still white and strong ice in place. This is Eagle in 2013. You know, clearly a mechanical breakup. Ice jam formed downstream of Eagle, and this is what you see through the jam. You know, jumbled ice, and then ice pushed over bank. So not only is there flooding, but there can be ice pushed over bank that causes damages. And that's what we see, or is one of the driver of damages, is ice pushed against buildings, structures, moved off foundations, things like that, in addition to the flooding that occurs. Where do they occur? So ice jams typically occur sort of in problem spots. The spots that come to mind would be Coffey's Bend on the Kuskokwim, Birch Crossing on the Kuskokwim, and this is Bishop's Rock, which is just downstream from Galena. So the river here is flowing from the back of the picture towards us, and makes a sharp bend, and then on the left you've got Bishop's Rock itself that constricts flow. And so when we're out there flying, we're typically looking for the problem areas. What does the ice look like just upstream of Bishop's Rock? Is it still strong? Sharp meanders, obstructions, islands, and then changes in slope or other areas we look for ice jam problem spots. So the Army Corps of Engineers has a great database where they track just the reports of ice jams throughout the state. And this is just a map from their database pulled that shows throughout the state of Alaska. We've had ice jams that have occurred, you know, on most of our major rivers. Yukon, Kuskokwim are the two we monitor nearly every year. The Koyukuk, we tend to monitor the Buckland River. But you can see that map covers basically the entire state. The shades of red are areas that have more reported ice jams, so it's higher frequency. And those you can see are mostly along the Kuskokwim and the Yukon River. So now I'll go back. We'll look at 2020. Just as a recap, 2020 was mechanical. It's got some good examples of what we see on our rivers, problem spots. The outlook we had last year was for a mechanical breakup as well. You know, it's really difficult. There's no forecasting tools that can predict where an ice jam will occur or how high the water will be. We've got indicators that help us lean towards it's going to be mostly thermal, mostly mechanical, and then other great observations from on the ground that can sort of highlight problem areas themselves. If we look at the same Corel ice jam database, we just pull out the number of jams over the last 20 years, you can see that from 2014 to 2019, we were in a sort of different period where we had warmer winters, less snow in some cases, and we generally had just mild breakups. Last year, 2020 circled mechanical, and we did have ice jams reported throughout the state and a few significant ice jams. So I think we want to let people know that when we say average, we don't mean 2014 to 2019. We're sort of average throughout the last 20 or 30 years. So an average year, we do see ice jams form. Last year, the Kuskokwim at Napaimute had a major ice jam that caused major flooding. That jam stayed in place for several days. One thing to note is locals, elders, they knew that there was a midwinter breakup on the Kuskokwim near Napaimute, and so there was concern for that area. And so that is one thing we try to track each winter is where problem areas may be. We really rely on local community information sharing, and we try to get that back out to the other communities, and they do as well. So it really works well up and down each river. Further downstream, the Napaimute ice jam stayed in place and the ice downstream weakened. And so after that release, we didn't see the continued ice jam flooding. I think partly because the ice weakened over time downstream, which was beneficial for those communities, but there was still high snowpack in the Kuskokwim. And so we had moderate snowmelt flooding in Kwethluk and then New Napachuck as well. Over in the interior, we had a sort of unique event that happened last year. Basically mid-April, around the 20th, 24th, we had rain from Amonic all the way through Eagle, Alaska, which was unusual for April. April tends to be dry, and that caused sort of the rapid onset of snowmelt. And what we saw were that medium-sized rivers throughout the state broke up early. Chena River, rivers around Galena, rivers up near Eagle, but it was restricted to the smaller and medium-sized rivers. We didn't see the Yukon start to break up. We were worried it would, but it didn't. But in Fairbanks, they had ice jams through Fairbanks proper, upstream of Fairbanks on the Chena River. And this is just a picture from just below the Moose Creek Dam on the 23rd ice jam. And then the Corps of Engineers operated the Moose Creek Dam to mitigate downstream ice jams. And that was unique last year. Similarly, on the Tanana, later in May, there was an ice jam that caused water to flow into the Moose Creek Dam project. This is a picture. It's a relatively small ice jam just at the end of the floodway, but it was enough to elevate the water and cause it to flow into the floodway. I'll just go through a few of the highlights from last year, other problem ice jam areas. Bishop's Rock did have an ice jam that formed and water rose 5 to 10 feet at Galena rapidly. No impacts that released and cleared, but it was one we monitored. Aluckinock had an ice jam that formed downstream. The Yukon River has 3 exits, and the southern exit had an ice jam that backed water up into Aluckinock. Ice jam near McGrath. Sleepmute had an ice jam prior to the Napaimute ice jam that had overbank flooding, and then a few others there below. These all were ice jams that caused overbank flow, but generally limited to minor flooding with just inundation, no major impacts. So now we'll sort of look forward to 2021. 3 things we really focus on when we look at consider our outlook are ice thickness, and the aerial extent. So do we have ice all the way up into the headwaters? Is there unusual ice formations downstream? On the North Slope, we try to get information on off ice, which is ice that forms from sort of ground seeps. Sometimes it's ice that forms from a river. It's separate from river ice that's floating. It's generally attached to the riverbank or overbank and causing issues on roads. And then the other big thing we focus on are dumpled ice formations or areas we had midwinter breakups. The Napaimute last year we knew about, and there was concern for that specific area. And so, we look to communities to help us with that information. We do our best with the tools we have, but often we get the reports from whether it's somebody trying to travel upstream, downstream. That's always a great indicator, like, too difficult to travel. It's jumbled, hard to put in a snow machine trail or ice road. The second thing we look at is snowpack. How does it compare to average? Is it a heavy snowpack year, light snowpack year? And then the third component is spring weather, and that's the most important component when it comes to severity of flooding and ice jams. And it really drives whether we trend towards thermal or mechanical, and how severe our ice jams could be. There's sort of best case scenarios that we'll look at, and then a couple unfavorable scenarios that we'll look at. So those late April, May control two things: the snow melt in the headwaters of the watershed, and then the integrity of the ice downstream. And the idea is in a thermal melt or a mush out, you weaken the ice and you sort of slow the snow melt. And if the opposite happens, if you have a rapid snow melt like we did last year on our medium-sized rivers, early in the season, we still have strong ice in place. And so that's how it controls this relationship between mechanical versus thermal. So we'll look at ice conditions first. On the left is a map of, we call this freezing degree days. And so it's sort of, we add up all the cold of each day and try to look at how that compares to average. And so it's the accumulated freezing degree days over the season. And generally, if we've got average accumulated freezing degree days, we sort of consider that the ice is likely to be average thickness. And so the shades of white and light blue indicate near average or slightly above for freezing degree days. And that's for the entire winter of from October through where we are today. Then on the right, we've got a map of actual measured ice thicknesses. And this is really one area we struggle, is to get ice thicknesses year to year in the same location. Spot measurements are good, but really, what we look for is a measurement that we repeat year after year. And once we get, say, 10 or 20 years of record, it really helps us and local communities to sort of understand how things are this year compared to previous years. The one thing we look at with these two figures is that the actual measurements tend to back up the freezing degree days. And so we can sort of use those to extrapolate beyond the ice measurements we have. We do have two anomalies highlighted on the ice map. We've got a thinner than normal measurement in Galena. And we sort of, that's one area where we need to usually follow up, and we'll try to determine, is that representative of the entire area? Was it specific to that single measurement? And then the other area that we've got circled in red off to the right, that's an area where it's a jumbled ice formation. There were freeze up jams that occurred on the Yukon River between Eagle and Dawson during freeze up. And so that entire reach has got jumbled ice with water levels, at one of their highest levels as the river froze. And so statewide, that's one area we'll watch. And similar to Napaimite last year, is like an area of concern for ice jam potential. The next thing we look at is snowpack. The NRCS does a great job of monitoring the snowpack throughout the state of Alaska. The figure on the left there is their map, with shades of blue indicate heavier than normal, deeper than normal snowpack. Shades of red are thinner than normal snowpack. And so you can see the Kuskokwim is shaded 180% as of April 1st. So it's well above average for snowpack. And then the rest of the interior ranges from slightly above to slightly below, with the Koyukuk and the North Slope being slightly below normal snowpack. To the east, upstream of Eagle, we often look at the Yukon Territory for information. And if you look at the Yukon as a whole, it's above normal for snowpack upstream of Eagle. And so we need to coordinate cross borders. All their water runs off and drains past Eagle. And so that's where we look to the Yukon Territory for snow information there. Some of the highlights you can read on the left. The other one that we'll note at the bottom there is the southern half of the Seward Peninsula has got above average snowpack. And while ice jam threat isn't great, there's no large rivers for these larger ice jams. There's still a possibility for snowmelt issues, for local drainage issues. So I talked about weather being one of the most controlling factors. And we can look at sort of a best case, like what helps us during the spring to mitigate the effect of ice jams or the possibility of ice jam flooding. And I think 2012 is one year we can look at. The bottom left figure shows the map of snowpack across Alaska. We can see it's shades of blue. Generally, it was average to above average snowpack. The top right figure is the similar same freezing degree days. And we can see again there with shades of blue, where the ice was average thickness to possibly thicker than average. And so it was a year where we had the snowpack, we had the ice conditions, but 2012, we didn't have any major flooding. There were ice jams formed. There was some moderate flooding, but it wasn't widespread ice jam flooding. And I think it was a result of sort of the spring temperature regime. You can see on the plot here, just Fairbanks as an example, we ended up with a warm middle to late April. The shaded gray were the 2012 temperatures. And then in the background, the brown band in the middle is the normal temperatures. And so you can see that shaded gray is above the normal band in mid-April. And then it trends back into the normal band through sort of end of April and May. And I think that's sort of ideal framework is cause some snow melt, weaken the ice early, especially at lower elevations, and then just gradually work our way into breakup. The real key is probably snow melt on the rivers and weaken the ice early, and then sort of delay that those mountains headwaters snow melt. We can look at two examples of unfavorable sort of temperature regimes for breakup. 2009 is a great example. We can see that shaded band is in sort of just right in the normal range. Nice warm up through April, and then early May, late April, we had record temperatures throughout the interior. I was up in Fairbanks doing snow surveys, and I remember it 70 degrees just east of Fairbanks. And this was pretty much throughout the interior as record temperatures. And so that caused rapid snow melt still early in the breakup season when we had strong river ice, and led to ice jams throughout the Yukon and the Kuskokwim. So that's one example of unfavorable. The second one is cold spring. If we just get really cold temperatures from, say, early April all the way through the beginning of May, we delay weakening of the ice, we delay snowmelt, and then it tends to happen faster. We've got much more sun in May to really kick off that snowmelt. And then this is 2013, where we had ice jams at federally declared disasters due to ice jams at 5 or more communities. And you can see from about the first week of April through the second week of May, we were at or below the average temperature, and had record lows, 5 or 6 different occasions in Fairbanks. And then similarly, it carried down to McGrath. We saw same thing, not as many record lows, but below average temperatures for that springtime. And so that's sort of the second unfavorable, is just a cold spring that delays breakup. And those are both difficult to predict several weeks out. We have tools that we can lean towards above or below, but we don't have any tools that really tell us, like, oh, in 3 weeks we expect record warm temperatures. The weather models, NOAA, National Weather Service, working towards that, but it is a challenge to sort of predict or forecast those weeks in advance. What we do have are just like I mentioned, we have tools that can allow us to look and see if we expect above or below normal temperatures throughout the state. And so I grabbed one chart. This is the Climate Prediction Center. So this is the outlook. It's not a forecast. The forecast comes from your local weather service office and covers usually the first 6 or 7 days. This goes beyond, gets more into our breakup time frame. So just below the figure, this is for the third week of April 21st to 27th, sort of right in there when we're going to see the first locations on the verge of breaking up. And with the CPC, how we read this is sort of in those blue areas, it's more likely we'll see below average temperatures. And then in the shades of orange, it's more likely we'll see above average temperatures. So we'll call this, it's tilting towards cooler in interior eastern Alaska, and then down in the extreme southwest, a slight tilt to warmer temperatures. And we can look at these for different time frames, and we try to sort of collate that and then put that into our breakup outlook. But these do change. We have to look at these day to day. We'll get as the weather models, as the prediction systems get new information, they'll cycle through different solutions. Sort of a quick summary of where we think we're at for 2020 breakup outlook. We think that on most of our rivers, we're trending towards mechanical. It doesn't necessarily mean widespread flooding. Means that we think will be ice jams. We can get a good temperature regime that probably keep those less severe. We're really, at this point, we've got the ingredients, the ice and the snow, and so we're going to be focused on any of these unfavorable record war temperatures, or if we had some cold weather that continued for several weeks. As far as where the flood potential is on the Kuskokwim, we've got that as above average, and that's based on the ice conditions and the snowpack. And then also on the Yukon River, that area upstream from Eagle, we're concerned about. And so that would affect Eagle and potentially affect areas downstream. When an ice jam releases, it releases that water. And so there's the potential for downstream flooding due to the release of the ice jam. Other areas of the state, the North Slope and the Koyukuk, we generally think is below average based on the information we have now in terms of snowpack and off ice conditions. And then the rest of the state is, in the average flood potential, which is that longer term average. Goes back, you have to think back maybe 20 years. It's not average for the last 6 or 7 years that have been relatively mild breakups. Just a table view that's got the same information. Really, the highlights are that the Kuskokwim and the Upper Yukon above average, and it really be the temperature regime that drives how far mechanical versus thermal we are. We take that sort of regional information and put it into a graphical map. And this is what we call our flood potential map that was created last week, and it's just site specific. Gives a community flood potential from low to high. You can see that we've got Eagle, that's easy to identify and circle in the moderate area, and then sites along in the Kuskokwim in the moderate flood potential. And it's based on the history of that community flooding. Some areas are prone to ice jam flooding, and some aren't, generally related to where they are in relation to the river. The other thing we try to look at are breakup dates, or when we think breakup might occur. This is a map of the average breakup dates across the state. You can see that the Yukon breaks up right around May 4th up in Eagle. So that's sort of the start of breakup on the Yukon River. And the way rivers break up, they break up from their headwaters down through the main stem. And then the last sites to break up are going to be down close to the ocean. So the Yukon starts around May 4th. And then if you look all the way downstream, you can see on the 21st of May is in the Ammonik-Alukkanuk area. So it's about a 2.5 week breakup on the Yukon. The Kuskokwim, I've got underlined is Nikolai, and that's always the site we look at as one of the first areas to break up in the state. And it's one check of where we think we are in the breakup cycle. Does Nikolai go out before the average date or after the average date? And that's coming up soon, in the next 7 to 12 days. The average date for breakup in Nikolai is the 23rd of April. Some years I'll give this talk. There was one year, I think 2016, Nikolai had already broken up by early April. It was sort of remarkable how early things were. So these are the average dates. And then what we try to do is use the climate information we have and come up with an estimate or outlook of where we think the timing will be for this year. And this helps in the planning process. I think, right now, this is the time to plan and prepare. It's not on May 3rd in Eagle. It's like second week in April, well in front of when we think it could possibly break up. Plan, move things, and get your plans in order. So here's where we think we're at for the timing to break up. Sort of the caveat is, like I mentioned, those climate outlooks change as we get closer to breakup. But generally, in the southeast portion of the mainland, Alaska, we think it's going to be early. are late on the order of 1 to 3 days, and then the rest of the state, we estimate it's going to be late on the order of 3 to 5 days. But that can change, and that will change, and we'll update these products as we get new information. But generally, where we are right now, that's about where we think we're at for timing. Slightly delayed, maybe average to a few days late throughout the state. So next, we're going to watch a short Riverwatch video from 2015 that I think they'll queue up, and then we'll talk a bit more about Riverwatch itself.
People are in their village, they can't go out, and they don't know what the ice is doing. So with information like that, it prepares the people, and they have knowledge, about what's happening in their area, and that can go a long ways. Yeah, good evening, Tuluksak. This is Riverwatch. Nagtanong kapatungokot kaya siniwi tangik tugot little bit of a report on the upriver ice. The end of the ice run is at Chowakpalak, about 1.5 miles, and it appears to be ice-free from there.
All emergencies are local, and so in working with the communities and in working with the scientists over at the Weather Service, we're able to join together some important partners in dealing with emergencies and preparing for them, and just doing our best to keep each other safe.
The significant ice is between Aniak and Kalskak and Coppice Bend.
Would you characterize this as a jam or more of just a place where it's rotting in place?
I'd call it sheet ice in place.
The Kuskokwim and the Yukon are unique, and we actually fly them, but there's also the Koyukuk, Buckland, the Noatak, and so those are more, we're calling communities, finding out what's going on, trying to give information back, provide information that we've heard back to those, but the Kuskokwim and the Yukon are the two that are unique, where we fly each year.
Riverwatch is a great reason to reach out to the communities. Everyone's interested, everyone's already ready to talk to us, so we just give them a call, touch base as often as we can with pretty much anyone who's willing to answer the phone for us, make sure that we have information and can contact all of the communities if there is something happening any time of the year.
A lot of calls that I got, we're wondering if is that it? Is there no more ice upstream? Yes, there's 60 miles of ice that's above Bethel, still yet to come down. I do enjoy reading river ice and watching breakup. It's, to me, a very important time of the year for, a river. A river is our lifeline.
I think the video really describes the Riverwatch mission. It's the state, it's the Weather Service, and it's local community elders, sort of sharing information, monitoring the rivers. Our mission from the Weather Service is to protect life and property. And so, our goal is to identify ice jams, make sure that people are alerted upstream, and then also people downstream understand what's happening upstream, what could be the potential. Last year we had the Napaimute ice jam, and we had flood products issued areas downstream. And so it's really that information sharing. And Riverwatch is like it was shown in the video, it's direct. We're in the plane, and we can usually relay directly to communities on the ground or land afterwards and have a call with communities on the ground. In addition to the Riverwatch, which we were able to do almost normal last year under COVID, and we plan to have a similar mission this year. COVID's on everybody's minds, and that's part of the planning process. But we are able to. It's that important that we're able to keep that mission going. So it is a partnership with the state of Alaska and the Weather Service, and then really local communities to help us understand. Share out the problem spots that we know about, so that people can prepare and know what's happening upstream. The other thing too is Peter mentioned in the video, is navigation. People do want to, once the river's open and safe to navigate, people want to get out there with boats. And so, one of the things we look for is ice that could still be upstream, and let folks know that there could still be runs of ice downstream. A couple of other tools we have, we use more satellite technology now. We've worked with several universities over the years. We've got a National Water Center in the lower 48 that can help us classify, basically take an image from space and classify it into ice or no ice. And so we're starting to use more of those techniques. But in general, that technology is not there to identify an ice jam and sort of determine what we think in terms of, is this jam going to be significant? And so that's where the River Watch mission is really important. Wanted to just touch on this. It's an EM conference this week. We worked with the state to get this identified as Flood Preparedness Week. A few stats there. Really, the idea is this is before breakup. This is the time we can prepare. There's a few things we can do. Really straightforward. There's a lot of online resources. The state has some, FEMA has some, but really it's, prepare before, be ready to take action during, and then have an idea of what you're going to do afterwards. I've been around Alaska, nowhere near the experience of Peter or some of the other elders we work with. But in the last 15 years, preparation could be, if you own a store in a certain community, to elevate your merchandise. I know some stores just do that every year, regardless. It could be to move snow machines, vehicles to higher ground in preparation. So there's all those little things that can be done ahead of time. Communication is always a big one for any type of event. So have that identified. The other thing we really like to highlight is that, as we get into spring, people are probably still traveling on ice. And so it's really think about the ice condition. And that's really a local decision. I think it's, really important to, kids, anybody that's not aware, is just make sure that you've got the ice conditions in mind. And so sort of think about the ice it will get to a point where you can't travel, and we want to make sure we're off it before it's not unsafe. The last thing I'll try to get through here quickly is our observer program. The Weather Service, we rely heavily on the USGS. This pie chart is just all of the gauges or remote equipment that monitor rivers. And so the USGS, the United States Geologic Survey, federal agency, they're the primary supplier of river information in Alaska. And then I wanted to highlight sort of in the bottom left, we have this National Weather Service Daily Observer. We have about 20. I would say 20 formal, and then we probably have another 30 or 40 informal observers. But that's where we use sort of citizen science observers to augment our river conditions throughout the state. And it's really valuable. The program started in the 50s, and it was sort of before automated equipment, the way to get river information to the River Forecast Center and help people make decisions up and downstream. I'll just highlight one gauge, the Nushagak River, one of the most important rivers in Alaska, and there's no river gauge on the Nushagak. We've worked with community members in Istoyahuk, and so this daily river observation from just a local observer is what we have now for river information on the Nushagak. So there are still places in Alaska where we have entire rivers without a USGS gauge, and so these are valuable. We'll look quickly. This is just an example of how simple these river gauges are at our local observers. This is on the Nushagak. And so what we do is Weather Service usually sends out a team. The key ingredient is finding somebody that's usually interested in the river anyway, or travels to the river every day, and get a commitment that, at least for the next 3 or 5 years, we'll do daily measurements. That's really what we look for, is just somebody, and usually people are interested. The rivers are how travel happens. It's where they fish, and so it's usually not hard to find somebody interested. But what we'll do is we'll go out and survey the riverbank, and then each day our observer will just measure. If we look on the right, we've got a survey monument in the foreground there. They'll just measure the distance from the monument down to the water level, and then we still tend to be telephone, and we'll get the call. And so every day we'll get calls from 20 or 30 observers across the state, and it's a chance just to during breakup, find out if anything else is happening ice jam related. During the summer, it can just be to hear about any other unusual river conditions, but usually it's just a call. They give a distance, and then we convert that to a river elevation, and then share that on our website. So it is a great program. We use the same program to get ice measurements. And so just this year, we increased the number of ice measurements we're getting in other parts of the state along the Kuskokwim specifically. But we're really interested in this program. And if there's a spot where we've got somebody who's interested, we can probably work with them to get a monitoring site set up. I'll sort of end on this slide. This is the Tana River on the 12th. And it's sort of a picture we usually put at the end. Some recent years, there's been no snow in the background. And so this is sort of, I think, back to the longer term average where, breakup really hasn't started yet. We are getting warmer temperatures, but it's still all ahead. Now's the time to prepare. We've got the outlook out. And so really this is where sort of the work begins between the state and the Weather Service and local communities to start monitoring and stay prepared. A few links to some of the maps I showed, and then link, email, telephone number for any observations. If you know of one of these midwinter breakups, problem spots that I didn't talk about, we'd love to hear about it. And I think with that, maybe we'll see if there are questions.
Yeah, that sounds great. Thanks for the presentation, Crane. That was a lot of great information. So I'm going to jump into some questions here. The first one is from Tawny Boothby. She's asking, can the spring analysis that you have done for the 2012 Fairbanks best case scenario be accomplished for Mat-Su? In 2012, we did have significant flooding. It would be nice to see that analysis based on current projections.
So the 2012, that was just Fairbanks an example. And I can't see the chat, but 2012, was that breakup?
I think she's maybe looking at kind of correlating 2012 with what happens in the Mat-Su. If there's any products for kind of forecast based on the Mat-Su for this year.
2012, I know flooding in the Mat-Su, there was significant rainfall flooding in late summer, fall 2012. We'd have to look specifically at breakup flooding. One area of concern in the Mat-Su is sitting at Gold Creek has had ice jams that cause major flooding, and the main impact is the railroad. But so that 2012 from Fairbanks is just an example of a good pattern. It's not really an analysis of this year's temperatures, but we could definitely look at how 2012 played out for the Mat-Su and see where that one was.
Yeah, Tawny, maybe if you want to send an email after this with your question, maybe folks can get some more information after the conference here. We have a comment from Asha Kamarov. She's saying, when I was younger, my late father used to say 2 weeks after Nenana ice breaks, the lower Yukon breaks. Based on your records from your slides, he was right all along.
Yeah, I would say, Asha, that we tend to run the numbers, and then we tend to just match what people out in the communities already know from watching it every year. So that agrees with what my experience.
We have a next question from Jerry Stackhouse. Yes, with the proliferation of drones, are there plans to start using them in this process?
Yes, and we are working on that. Every state, federal agency has sort of the process to work through. So one area that works well to incorporate drones is that citizen drone pilots, if they've got interesting footage or they know about an ice jam and they capture footage, that really helps us. That's one way that folks out in the communities can sort of become part of the process. So a lot of times we'll get those shared on Facebook or other social media. So it's really simple to share those with us. We would like to. The one problem with drones and the one thing that's hard to replace the plane that can fly, these distances on the order of 50 to 100 miles that we've got to cover even longer. And so, we're not there with drones yet to fly, say, the entire Kuskokwim.
Yeah, absolutely. If anyone has any questions, feel free to drop them in the chat. I have a couple, but I'll start with, does Canada have a similar program to this for like Northwest Territories and everything?
They do. So in the US, river forecasting is at the federal level. And then in Canada, it's at the provincial level. And so the Yukon Territory does a similar river watch. Alberta has a strong river watch program where they actually do aerial monitoring just like us. And then Quebec similarly has aerial monitoring. So it's more difficult to sort of compare to Canada because it's different it would be like each state doing its own program, whereas here it's the federal does the river forecasting, but they do, yes. And we collaborate closely with the Yukon. So we'll talk and sort of share notes on the Yukon River and then the Porcupine.
Awesome. And I was wondering, we got a lot of comments here and great presentation. I think people really appreciated that. One last kind of question I have is for folks that are interested in doing the kind of citizen science model. Can they just send you an email to learn how to do that, or how do you get hooked up with that?
They can email, and then eventually it'll be a phone conversation to try to find out. I see Asha's how much local knowledge. We try to tap as much as we can. I think the video sort of shows that, in that case, Peter Atchek, for several years has come up and flown with us, and they really, that's important.
Absolutely. Well, we're coming up on the top of the hour here. So once again, Crane, I really appreciate the presentation and thanks for spending time with us at the conference today.
Thanks for having us.
Yeah.
Thanks for the comments. Thanks for the chat comments. Those are all great.